Hey everyone. In this video we're going to start talking about exponent rules. So we are at a point in the course where we're going to start talking about exponential functions, where we start having a variable in our exponent. We're going to look at a lot more exponents. And so to do that appropriately, we need to really understand our exponent rules. So what I mean by an exponent rule, it's how do exponents interact with one another. So if I was looking at something like 3 squared times 3 to the 5th, I have two different numbers that are represented with an exponent. So this one has a 2 on it, and this one has a 5 on it. And the question I have is, well, how does this 5 interact with this 2? Can I combine them some way? And depending on how we're combining our numbers, so we're multiplying these two numbers here, that gives us a rule. So based on how we're going to combine our numbers, we'll get different rules. So in order to answer this question in front of us, what I want to do first is talk very quickly about what does this mean. So if I have a 3 with a little 2 up above it, what that means is I'm going to take 3 and I'm going to multiply it by itself 2 times. Okay, so I'm going to have a 3 times a 3. So there's 2 3's in total here that are being multiplied together. And so 3 squared, this is 9. And so 3 to the 5th, this would be 3 times 3 times 3 times 3 times 3. Did I get them all? 1, 2, 3, 4, 5. So 5 3's all multiplied together. And the question is, well, if I were to multiply all of these 3's together, what would happen? And so when you break things down like this, understanding the definition of notation is pretty important. And so that's why I went through this over here on the side. All right, so let's take this 3 squared times 3 to the 5th, and we'll see what happens here. Okay, so this is equal to, well, 3 squared is 3 times 3, like we said before. Okay, so that was my 3 squared. Now 3 to the 5th is, as we had over here, right? So this is going to be 3 times 3 times 3 times 3 times 3. And I'm multiplying all of these things together. Okay, so I have 3 times 3, that's 3 squared, times 3 to the 5th, which is 3 times 3 times 3 times 3 times 3. Well, going the other way with my notation, I have a bunch of 3's here. How many do I have? I have 1, 2, 3, 4, 5, 6, 7 3's. So another way to write this would be 3 to the 7th. Okay, so I have 7 3's. Now where I got that from was I had 2 3's here plus 5 3's over here. So if I wanted to think about it a little bit broken down, this is 3 to the 2 plus 5. So 3 squared times 3 to the 5th is equal to 3 to the 2 plus 5. So if I have the same base, so I have 3's here, and I'm multiplying them together, what I can do with my exponents is I can add them up. And the understanding behind that is all right here. This is the number of 3's that you have. And when you multiply them all together, you just add up the number of 3's. And so in general, this gives us our first exponent rule, which says if I have numbers that I'm multiplying together that are raised to some exponents, right? So if I have some real number a to the m power and some real number a to the n power, when I multiply them together like this, the result becomes a to the m plus n. Okay, and so this is our first exponent rule. All right, so for the rest of this video, I'm going to go through and I'm going to talk about a few more exponent rules. So I'll get this cleaned up and I'll come right back. All right, so what I've done is I've cleaned this up and I've moved our first exponent rule up here into the top right. And we'll get started and see if we can make sense out of another exponent rule. Well, if I had numbers that I was multiplying them together, and I added the exponents, the next thing I think about is what happens if I were to divide those numbers. So we had this number before, 3 to the 5th, and what I want to do is I'm going to divide by 3 squared. So let's see, what does this mean? So the 3 to the 5th, as we saw before, this was 3 times 3 times 3 times 3 times 3. So I have 5 3's up top. And down at the bottom, 3 squared, this was 3 times 3. So what happens with division is if I have the same factor on top as I do on the bottom, those things can cancel out. So like this 3 right here and this 3 right here would cancel out. And this 3 right here and this 3 right here would cancel out. And what I would be left with is just things in my numerator. So this is just 3 times 3 times 3. It looks like I have 3 3's there. And, well, I could write that this way, 3 cubed. Well, hopefully this gives us some insight. So if you're thinking about this, what I want to know is if I had some number, like I did before, I had a to the m, and I were to divide it by a to the n, I'm asking myself, what would the end result be? So if you're not sure, I would pause the video here and take a moment to think about it. See what's happening with the example that we did above, and see if you can come up with what the rule should be. All right, so our rule, a to the m divided by a to the n, gives us a to the m minus n. So if we look up here above, 3 to the 5th, we had 5 things on top, and essentially what we're doing is we're taking away 2 of them because we're dividing by them. Right, so I had 5 things on top, I had 2 of the same thing on the bottom, and when I divide them, I'm taking them away. So I had 5, I took away 2, and when we think about takeaway, well, that leads us to subtraction. And so hopefully that makes this rule down here make a little bit more sense. All right, so if I have the same base in my numerator and denominator, when I'm dividing, I can just subtract my exponents. So I can take the exponent in my numerator and subtract the exponent in my denominator. Okay, so this gives us our second exponent rule. Okay, so I'm going to clean this up. I'll bring our exponent rule over. We'll come back and talk about a third one. All right, so we are back, and we're going to talk about one more exponent rule for this video. So what we've seen so far is if I am multiplying 2 numbers that have the same base, I can add the exponents. If I'm dividing 2 numbers with the same base, I can subtract the exponents. And now what we're going to see is, what if I have 2 sets of exponents? So we were looking at these numbers here. We were looking at 3 to the 5th and 3 squared. But what if instead of multiplying by 3 squared, what would happen if I took this number right here, 3 to the 5th, and then I raised that to an exponent? So this is what we call, we have a power to a power, or an exponent to an exponent. And so in this situation, what we want to do is think about what's happening here. What is going on? All right, so inside of my parentheses, I have this 3 to the 5th. I know that that's 3 5s. Right? It's 3 times 3 times 3 times 3 times 3. And I'm going to take that number and I'm going to square it. So I'm going to multiply it by itself. So let's go ahead and let's resolve this square and see what we get. Okay, so this becomes, well, if I'm squaring something, that means I'm just going to multiply it by itself. So I get 3 to the 5th times 3 to the 5th. So this is the same as 3 to the 5th squared because I have some number and I'm multiplying it in here twice. So this 2, there's 2 of them, so I have 3 to the 5th times 3 to the 5th. Well, when I break this down, this 3 to the 5th, what it gives me, I'm going to write it down here, it gives me 3 times 3 times 3 times 3 times 3. And this 3 to the 5th gives me the same thing, which is 3 times 3 times 3 times 3 times 3. And I'm multiplying all those together. So if we count these up, we're asking ourselves, how many 3's do we have? So I have 5 here and 5 here. So I have 10 3's. So another way to write that is 3 to the 10th. So if I come back up here and I think about this, I have a 5 and a 2. And so how do I combine 5 and 2 to get 10? A good guess would be that we multiply them. And so hopefully this gives us some understanding of our next exponent rule. So when you have a power to a power, or an exponent to an exponent like you do here, a to the m to the n power, what I'm going to do is multiply my exponents. Okay, so the end result for this becomes a to the m times n. Okay? And so this is our third exponent rule. Okay, so first exponent rule that we discovered today was if I have two numbers with the same base and I'm multiplying them and add the exponents, if I have two numbers with the same base, I'm dividing them, I'm going to subtract the exponents, and if I have a power to a power or an exponent to an exponent, I can multiply my exponents. All right, so these are our first three rules where we see I can add, subtract, or multiply exponents. So what we'll do is we'll come back with another video where we talk about some more exponent rules.